This is the leading coefficient test. First, before we get into it, I want to look at another polynomial function and then identify a few things of that function, and that will help us with the definition of the leading coefficient test. So let's say we have f of x is equal to 3x to the fifth power minus 7x cubed plus 8x squared minus 1. So this is the polynomial function that I'm giving you, and I just want to identify a few things in here. The first thing to identify is what this number is. And then we need to identify what that number is. Okay? So the one in the box up here, that's an exponent. We all know that. But relative to this polynomial function, what is that exponent? It's the highest exponent there is. So this is the highest exponent, so that's called the degree. The degree. And we're going to label it as n from now on. N is equal to the degree. The degree simply means highest exponent. So when you see n is equal to 7, that means the degree of that polynomial function is 7, and it's the highest exponent of that function. Now, this 3 here is called a coefficient. The same thing with this minus 7 and this 8. They're all called coefficients, but this one's special because it's attached to the degree term, or it's attached to the highest exponent. So this is what's called a leading coefficient. All of them are called coefficients, but this one is more special. It's called the LC, the leading coefficient. And so knowing these two things, the degree, n, and the LC, the leading coefficient, will help us with the leading coefficient test. Now let's define it. And make sure you have enough room on your paper for what I'm about to do. So I'm going to write just maybe a sentence up here. Then I'm going to have to use the whole board just about. You'll probably need the width of your page. And I'm just going to I'm going to draw a table. And it's going to be kind of big, but it will be helpful in the long run when you go back and look at your notes to help kind of remember what's going on. So this is the leading coefficient test. And the reason we need to learn the leading coefficient test is our end goal is to be able to graph any polynomial function that I give you. So the one I just erased off the board, eventually we're going to be able to get to the point where we can graph that without just plugging in our calculator. You're going to be able to pick out several different things from a polynomial function. And this is the first line of attack. And this helps you with end behavior. What happens on the very far outside of the graph? Do they both go up? Do they both go down? Or do they alternate? And so this is real helpful. This tells us end behavior. It doesn't tell us what's happening in the meat, in the middle, but it's still very helpful. All right? So the leading coefficient test, I already said this, determines end behavior And I wrote this a second ago, but we're going to write it just so you have it in your notes and it all flows. Let the degree, which is the highest exponent, be denoted by n. All right, so this is how the leading coefficient starts and is set up. And then we're also going to have the LC, which is the leading coefficient. All right, let's get started here. So we're going to have, I'm going to make it pretty big. As long as you write kind of small, you can fit it on the width of your page. Just so you can see easier, I'm going to draw kind of big here. So I'm going to draw a long line, and then I'm going to break this table up in half. And then I'm going to break each half, just like this, into other halves. So what's going to happen is we're going to have 4 options here. Just make sure you have kind of 4 equal boxes there, and then we're going to have other subsets up here. So first, number 1, we want to look at, when we're doing these, you always look at, you can do it in either order, but for us, it's easiest to look at what is the degree. So we look at the degree and we determine if the degree is even or odd. All right? So here, if n is odd, so these 2 boxes are going to be only if n is odd. Then you're going to have 2 choices. If n is odd, you're going to have choice A, and you're going to have choice B. So we've already determined that our n is odd, so the only thing left to determine now is the LC. That's what the leading coefficient test is. You determine if the n is odd, and then now we need to look at the leading coefficient and determine if it is positive or negative. So part A, if LC is positive, the graph, that chalk is getting way too small, so I'm going to have to switch on you. The graph falls left and rises right. All right, that means it's going to go down on the left, down on the left, and then up on the right. And I'll show you, when I get all these up here, I'll talk you through just kind of in your head how you can do these to make it a little easier. All right, so we have if n is odd, and we have our 2 options. If n is odd, and here's our positive option. Now if LC is negative. So if LC is negative, then the graph, I'm supposed to say graph rises left and falls right. So what that's going to look like is it rises on the left and then it falls on the far right. And when you're doing homework and you're doing this section, or when you're graphing the whole thing, draw these arrows like that. It will help you, especially when you get to the big graphing section. So here's our 2 choices for when your degree is odd. The LC is positive or negative. Now we have to move over here to option 2, which is if n is even. And then we're going to have 2 options there. It's going to be the same options as over here. The LC is positive and the LC is negative. So part 2, if n is even, then we have part A. If LC is positive, then graph, let's think about, you can do this one. Let's think about our quadratics. If we have a quadratic, that means its highest exponent is 2, and it looks like an upward cut or a downward cut. And then we just have to worry about what A is. So if it's even, like the x squared, we know they're both going to go up or down, and then we determine if it goes up or down by by A. which is the leading coefficient. If A is greater than 0, which is positive, that means both ends go up. So both ends rise. So up and up. Okay, think back to when we're working quadratics in the vertex. Part B, if LC is negative, then the graph I guess this doesn't make a whole lot of sense. Then graph both ends rise. Then both ends rise, we can say. So if the LC is negative, then both ends fall. All right, again, think back to our quadratics with x squared, and we're looking at a. If a is greater than 0, then then it opens up. If a is less than 0, it opens down. And so that tells you which way your ends are pointing. All right? So let's just think of it like this. Start with your odd here. If you have an odd degree, then that means the ends are going to do opposite. Odd and opposite. O and O. Odd and opposite. So if the degree is odd, the ends are going to do opposite. So you're halfway there. Now, if the LC is positive, then that means it falls left and it rises right. So remember, we read graphs left to right. That means if it's positive, it looks like a positive function. So it goes down on the left and up on the right. So try to think of it like that. If n is odd, the ends do opposite. So they go different directions. If the LC is positive, then it looks like a positive increasing function, down on the left and up on the right. Now, if n is odd, that means the ends do opposite. Then we have the LC is negative. So it looks like a negative or a decreasing function, up on the left and down on the right. So that's a real simple and easy way to remember that portion there. Just break it up into chunks like that. The degree is odd, ends do opposite. If the LC is positive, it looks like a positive increasing function. If the LC is negative, it looks like a decreasing function. Then n is even. This one, once we talk about it, is kind of self-explanatory. It's just getting in the mode of what's my degree, what does it mean, what's my LC, and what does it mean. So if n is even, my degree is even, that means that both do the same. They're even. Even means the same. So if all you remember is odd is opposite, then by default these have to do the same. But if you think of even as they do the same thing, then that gets you there. And so if n is even, they do the same. If the LC is positive, they're both positive, up. If the LC is negative, then they're both negative. They're both going down. All right, let's look at an example. We'll call this example 1. And it'll say something, determine end behavior, or use the leading coefficient test to determine end behavior. I'm just going to write determine end behavior. Determine end behavior. And here's part A. F of x equals negative 4x squared plus 3x minus 9. So I'm starting with something that we already know how to do, because we looked at this quadratic form in a previous lecture. So what I want to do, and it's also a good little review, is let's go back to that section and work it that way. And then we're going to work it this way with end behavior also. And we're going to see what happens. What happens is, when we're in this quadratic form, we need to look at what value? We need to look at the A. A, right here. It's a -4. So, I'm dealing with a quadratic, we already know that, because the highest exponent is 2. So I know I'm going to be going up or down. It's a parabola. So an up U or a down U, a cup or an upside down cup, whatever you want to look at it as. And now, if I know what my A is, it's -4. And if I think back to that lecture, if A is greater than 0, then it opens up, and that gives me a minimum. Okay? That means both the ends go up if A is greater than 0. If A is less than 0, it opens down, and it forms a max up here. So my A here is less than 0, so both ends go down. And so that's an easy way to do that. And so let's look at end behavior now and do it that way. So for end behavior, I need to know my n, which is the degree. The degree here is the highest exponent, which is 2. So remember, and now let's write, is 2 even or odd? 2 is even. So that means the ends do what? Remember, O, odd is the opposite. So that means even, they do the same. Ends do same. Not right proper English, but ends do the same. So I know they're both going to go up or they're both going to go down. And what determines that is the LC, the leading coefficient. Or in this case, it's A. So the LC is -4, which is negative. So that means both ends fall. There you go. So 2 ways to do it. A previous way we learned, and now this new way. Now this new way, this leading coefficient test, is very useful. So when we have a quadratic or something of this form, we know how to do it 2 different ways. But when we start getting into something much bigger, that's where the leading coefficient really comes into play. So let's look at part B. Something a little bit bigger, longer, or at least bigger. Let's say we have g of x equals x to the 7th power minus 5x. So it's short, but we have bigger numbers in there. But this still gets the same idea across. All right. So try to pause the video and do it yourself too. I think that'd be good practice. First, we need to identify the degree, n. N is the highest exponent. Here it's 7. 7 is odd. So that means ends, O and O means ends opposite. Ends do opposite. Ends do opposite. So that means one side's going up, one side's going down, and what determines which side is the LC. Our leading coefficient here, nothing's written, so that means it's 1. 1 is positive. Positive, so it's odd, so they're doing opposite. And this is a positive LC, so I know it looks like a positive increasing function. So I'm going down on the left and up on the right. So down left and up right.